Polar has a couple pieces, components. There's a polar axis, and as I say, it's going to look like concentric circles. You can flip the page probably and see I put some grids in there. You know, like here's a grid. That's a polar graph. So you have all your angles, you know, put in like we're accustomed to, but then there's these circles. So maybe this is a unit circle that's inside. You can make that distance as 1. And then the second one is a circle with radius 2 and a circle with radius 3 and so on. And you see these ordered pairs that will be listed. Okay, so we're going to deal with ordered pairs, but it's not the X and Y. They're R's and thetas. R's and thetas. So the theta sounds familiar. Hey, there's the theta right there. The R just stands for the radius of the circle you're talking about. So the position right here is described as a radius, a length right here of that line segment, and the standard angle position right here. Now, if I did, which I will demonstrate actually, if I did like this and extended it and made it look like an XY axis, wouldn't this be in quadrant 1 then? This is quadrant 1. Oops, this is quadrant 1, 2, 3, 4. If I put a dot right here, right there, and it's the XY concept in your brain, well, gosh, X is a little bigger than Y. X might be, you know, these aren't grids, but there's something about 3 right here. Gosh darn. Wouldn't you say that the X is a little bigger than the Y? Mm-hmm. They're both positive at least. So then you're going to be converting what's called polar, what do you call these? Polar coordinates. You're going to convert the polar coordinates into rectangular coordinates. You know, rectangular would be X and Y. This is R and theta right there. So I'll show you how to do that. Make the R's and thetas, use something to help you come up with the X and Y that would actually place this, let's see, about right there. See how that dot is right about there with the X and Y. So I'm going to show you how to do that. And then vice versa, if I gave you in, it's called rectangular form over here, and push it over into polar form, I'm going to show you how to do that. Okay, R is a directed distance or directed line segment from the pole. They call it right there at the, like the origin of the pole. And this is interesting. R could be negative or positive. R can be negative. Hold it, Jeff. You said radius. Radius is like hypotenuse. Yeah, I'm not talking about right triangles. There's no hypotenuse here. So it's going to feel a little awkward if you've never done this before, that you could have a negative radius. All that's going to do for you, the negative radius, is throw your point across the pole 180 degrees. It's going to have like a reflection across the, well, it's like with respect to the origin. And you'll see it when I do it, okay? Theta is an angle positive x-axis. Degrees are radians for the angle. Positive angles go counterclockwise, negative go. See, that's all the same. Positive angles go counterclockwise. That's the same that we've done. So nothing different right there. So there'll be some problems in your homework that'll say plot the point, plot the point. So in your notes, I'm going to recommend, suggest, that's soft pedaling it. I'm going to force you to think that you'll always do it this way, because then you won't get yourself in trouble. Do the angle first, then do the R. Do the second piece first, then do the R. Don't do the R and then the second piece. You're going to get yourself into trouble. At least I did as a student. So in your notes, oh my gosh, okay. Do the theta first, then do the R. Okay, that's what I'm telling you, that, and then you'll be fine. You'll be fine. So I'm going to find where 135 degrees is on the circle. So gosh, it's in between here. See that? In between here. Halfway in between. So I know I'm over here in quadrant number 2. The 2 just tells you how many circles out from the origin that you're going to go. So I'm going 2 circles. It's like a radius of 2. So first circle, second circle, then you put your dot right there, right there. And that's the ordered pair, 2, 135 degrees in polar form. Idea. Look at this. This right here is 135 degrees. What's this coterminal angle value? What's that coterminal angle value right there? The coterminal angle. Anybody? Positive, negative. Start there. Start there. Is the coterminal angle that I just drew positive or negative? This is the 135 right here. 135. So the coterminal starts the x-axis, hits the same terminal side. Is that positive or negative? Right here. This is an arrow right here.
Negative.
Correct. Okay. So we've established that's a negative. Now, to be coterminal, these 2 angles have to add up to 365. So what's that coterminal angle right there? Negative what?
Negative 230.
One more time there, Xenia.
Negative 230.
Okay, let's check it out. So does 230 and 135 give me 360? So that would be 365. Okay, you're off a little bit. You're going to tweak it a little bit, Xenia. What are you going to say then? It's not 230.
225.
There you go, 225. So this that ordered pair, polar form ordered pair, 2, negative 225, lands you at the same dot, lands you at the same place. Meaning there's infinitely many ordered pairs that will get you right there, infinitely. You just keep finding coterminal angles to the original, which was 135. Your author in your homework and group quiz and probably on your final exam will say, identify an extra or another polar ordered pair that lands you, it won't say lands you, but places you in the same position or quadrant as 2, 135. And that's an example of one. Couldn't I just take a 360 and add another 360 to this? Couldn't I subtract another 360 from this? I mean, here's another one. You can go 2, 360. That would be 495 if I did that right. That just goes a revolution plus a little bit more, and a little bit more is 135 degrees. So there's infinitely many ordered pairs in polar form. Okay, this one here, I got to go backwards. Negative 315. I think I'm over here, negative 315. Remember, I'm going this direction. I'm going that direction. So 315 is here, and I go 3. Okay, 1, 2, 3, put the dot right there. Negative 2, pi. Okay, so pi is a radian, but you know how to do radians. Do the angle first. So where's pi going to land you? It's going to land you on the x-axis, but over here, this side. Oh, now you got the stinking negative 2. Now, what does negative 2 do? It's the second part. You do the angle first. So right now, I know it's 2. So I would feel like, gosh, I want to put a dot right there. Don't do it. Don't put the dot right there. That would be 2 comma pi. I want negative 2 comma pi. So then what you do is you reflect it across the origin, and that's where the dot is. This dot is negative 2 comma pi, and it's also, let's see, 2 comma 0. It's also 2 comma 2 pi, and 2 comma negative 2 pi, and negative 2 comma 3 pi, and so on. It gets you the same place. Okay, this one here, negative pi over 4. Okay, that's over here. Negative pi over 4 is over here. And then 1, so you're going to put a dot right there. If it's a negative, it would have reflected, but it's not. I'm talking about if the radius was negative, then it would reflect. Okay. Okay, you may remember back in our trig sections, they're evaluating trig functions. Sine of 2 pi and multiples of the angle yields the same answer. So sine of pi, add another 2 pi. Sine of 3 pi, same answer. Subtract 2 pi from, well, what am I? Subtracting 4 pi from here. Subtracting 6 pi from multiples of 2 pi. Odd pies, any odd pi should get you the same answer. You don't believe me, I know you don't. So what I do is I put this in radian. Radian. Okay, angle, let's see, mode, there it is. You don't think it is the same, but it is, watch, radian. All right, so sine of pi is 0, I know that. I'll try sine of 3 pi. Okay, so you go sine of 3 pi, 0, sine of negative 5 pi. So sine of negative 5 pi. Yeah, 0. Okay, fine. So all this is doing is saying, okay, there is, here's my ordered pair, 2 comma pi over 4. So I did pi over 4 first and then 2. That will get me to the same place. See, this is 4 goes into 9, 2 pi's, and then a pi over 4 extra. So you whip around 2 pi first. Okay, so you go, and then you go pi over 4, you're still here, and you still go out to the 2. Oh, this is in the wrong place. Silly me, that's not in the right place. That's at a 3, that should be down here. I apologize for that. Right there. That's where the dot should be, right there. 1, 2, that was out to 3. Careless of me. Oh, this looks familiar. In a way, you can say, hey, Jeff, you said there was no right triangle, but it certainly look, if you got circles, you could create a right triangle. You can do that. You know that. I mean, what we're dealing with is r's and thetas, but you could drop a perpendicular to the x-axis and create a right triangle. So if you go over here and you say, anything that's a triangle would be a squared plus b squared equals c squared. So x squared plus y squared equals r squared. Guess what? That's the equation of a circle also. This is the equation of a circle centered at the origin. This is the equation of a generalized circle where h comma k is the center. Well, okay, if the center was 0, 0, 0, then you're right back over here. So this will be helpful. This is what you're going to need, this information. And then we're going to use definitions of trig functions that you know about. Sine is y over r, cosine's x over r, y over x for tangent. If you solved each one of these for y, somehow that's going to be helpful. There's your x. Okay, so gosh, if I go over here and I plot, yeah, let's plot this one. Okay, I'm going to plot it first. Do the rate, do the angle first. That's pi. So from here, I'm over on this side. Somewhere over here, I'm going to put a dot. And then you're saying 3. Oh, okay, so it's as if I go, I'm doing it lightly. I'm going to go like this. That's not very light. Huh? Okay, so I'm going to put a dot right there. But if this is the XY axis, which that's what we're trying to do, is convert it into rectangular. Well, that just looks like an I don't know, x-intercept. That looks like -3, 0. That looks like it, and it will be. I just have to show you how to find it, because this gets more challenging here. Find it. So if you're looking for the x and y, all you need is that. To go to rectangular form, you just need these two facts right here. That's all you need. You don't need this. So if y is equal to r sine theta, y is equal to 3 sine pi, y is equal to 3 times 0, because sine of pi is 0. Zenny, I just heard someone coming in, so, or maybe you just let them in. So thank you.
I got him.
Thank you. Likewise with x, x is equal to r cosine theta. R here is what, 3 cosine of pi. X is equal to 3. Cosine of pi is -1. And there you go. There's your -3. So that ordered pair in rectangular form, of course, was -3, 0. Rectangular. And this is your R, this is your theta. Okay, this is in quadrant 1. So the angle's about here. You know, pi over 6 is right here. Now I recognize there's a negative. So actually, instead of in quadrant 1, it's going to reflect over into quadrant 3. So think of it like this. Well, if you can see the little dotted line right there. So this is pi over 6 right here. This is. So instead of putting a dot out here at 10, you're going to go across over here and put a dot over here at 10 in that quadrant, because of the -10, the negative in front of the 10 throws it over there. And that ordered pair is what you're trying to find, actually. And so all you need to do is say x is equal to cosine, r cosine theta, -10, excuse me. Pi over 6. Cosine of pi over 6 is √3/2. And in like manner, you want the y. So this ordered pair that's right here is are these two numbers. The ordered pair is -5√3, -5. That's rectangular form. Okay, next one. Going the other direction, a little bit more work, not much, a little bit more work. Okay, this is the same information that's right here. Now I use this to find rectangular. I won't use this to find the polar, that directly. I want to use something else. So somehow I need to find an R and a theta if I'm giving an X and a Y. These are X's and Y's. So if I plotted in Cartesian coordinate system, the rectangular form, -2, +2 sits right there. -2, +2 sits in quadrant 2. So I'm thinking the angle is over here, probably 135 degrees, because it's halfway and smack dab in the middle, probably. The radius, I'm not quite sure. So what I'm going to do is I'm going to use this to help me find the radius. I use this to help me find the radius because notice I have X's and Y's. So all I have to do is go plus or minus the square root of that. So I'll use that to find the radius, and then I'm choosing to use this to find my angle theta. When I look at that, all I have to do is do a tan inverse. So theta is equal to tan inverse of y over x. Tan inverse. So I'm going to use the two circled concepts to help me find the r and the theta. Let's do the r first. So here I've got r squared is equal to x squared plus y squared. R squared is equal to -2 quantity squared plus 2 squared. R squared is equal to 8. 4 plus 4 is 8. And therefore r is equal to plus or minus the square root of 8, which is 2 root 2. Now I put plus or minus because you get to pick. You get to pick. So you got to be careful. Most of you will probably pick the positive, and that's okay. Now it's the theta. So I'm going to go theta is equal to tan inverse of y over x. Theta is equal to tan inverse 2 over -2, and I take my calculator and just let the calculator do the work. That'll be the easiest way, tan inverse. I'd probably put it in degree mode, which I was in radian, so over here. So tan inverse, that looks like -1. Okay, -45 degrees. Okay, I understand that. I'm going to show you another way besides this one too. So look at this. -45 degrees. That's this right here. Now you can use the -45 degrees, but are you going to use positive or negative 2 root 2? You could use this, that's fine, but will you use a positive or negative 2 root 2 to get you over here? Here's your negative pi over, or a negative, well, it can be pi over 4, but -45 degrees based on this formula. Okay, you're right here, but I want to be over there. I don't want to put my dot, whatever the r is, I don't want to put it over here. I want it over here. Don't do the 2 root 2. Don't do that one. You do the -2 root 2, throws it across the pole into the other quadrant. So if you're going to use this, you got to go -2 root 2 and use the -45 degrees. Otherwise, if you went 2 root 2, knowing that they gave you -45 degrees, you'd have to say, well, gosh, that's 45 degrees. It looks like 135. It looks like 135 degrees. But you got a couple choices there. So just be careful. I said I'd show you another way. So here's an idea. Ready for the idea? Ready? Yeah. Okay, you got a right triangle. You know this distance is 2. You know this distance is -2, not -3. That was weird. And you know you can find the hypotenuse the same way we did right here. Find the hypotenuse or the whatever that r, same way. So that's not an issue. The question is, I need an angle. Now, this angle right here is not the angle I'm looking for. I need to always start at the positive x-axis. I need this angle. So what I can do is find this angle, which is called the reference angle. Oh, it's been a while since we spoke about that. I can find the reference angle. As long as you understand that's a reference angle, that's not your answer. And you'll find out that's going to be 45 degrees. And then what? And then subtract it from 180, get you the leftover. I guess that's what you can do. Okay, so if I did that, gosh, this is theta, maybe. This is theta, so this would be a tangent. So we're back to, see, we're back to this. See, we're right back to that again. Tangent of theta is y over x, and we're back there. So in any case, you're just going to use the formula, I guess. Just be careful of what quadrant you're in. Yeah, that didn't help. Oh, gosh, let's see. Let's do this one. This is quadrant 3. Right there. Okay, I want to find r equals plus or minus the square root of -1 squared and negative square root of 3 squared. R is either positive or negative. Square root of 1 plus 3. R is equal to plus or minus 2. Square root of 4 is 2. Okay, now we're going to find the angle. And we're going to use this concept again right here. So theta is equal to tan inverse of negative root 3 over -1. A little tan inverse thing on here. Oh, that's just tan inverse negative root 3. A positive root 3, excuse me. I'm getting 60 degrees. Okay, I'm back over here. So I'm back over here. This is the positive 60 degrees. Right there, that's 60 degrees. But I don't want to, I mean, well, I can use 60 degrees, but I want the dot in quadrant 3. So the R would have to be negative if you're going to use 60 degrees, which is what I'm going to do. That's the easiest, I think. So the R has to be negative. So let's see, R. -2, comma, 60 degrees. And that would be the polar coordinate. Okay. Same set of statements here, same stat on the next page. when you look at these two equations, A and B, they sort of look familiar, especially A. That's just the equation of a line, this one here. Equation of line. That's what's called standard form, the equation of a line. AX plus BY is equal to C, right here. This turns out to be the equation of a circle, this one here. Equation of a line, equation of a circle, both in rectangular form. If I want, okay, let's do this. I know how to make the line here by doing the following. I'm going to make it y equals 3x subtract 6. So the old algebra says find the y-intercept first, which is 1, 2, 3, 4, 5, 6. Put a dot right here. And then the slope is 3 over 1. So up 1, 2, 3, right 1. Up 1, 2, 3, right 1. Take your straight edge. If you don't have a straight edge, take a piece of paper, fold it in fourths. There's my straight edge. Okay. So that's the equation of the line. So here's what we want. We want to find an equation, but that's a polar equation rather than the rectangular equation. So that if you replace values and you have two variables, that you're going to get infinitely many dots, that if you connected them, you're going to end up forming this line. So that's interesting. This is going to be an interesting thought when we're done. So say it again. We got a rectangular equation. We get an equation that's basically a function too. This is not a function, but this one is. And it looks like this. And if I want to convert it into a polar equation, somehow you get rid of the x's and y's. Polar does not have x and y's, only r's and thetas. So get rid of the x and y. And that sometimes a little challenging. I'm just going to look to see what I could use up here to help me get rid of x and y. Well, let's see. R, I got a y here. I don't have an angle. Okay, let's see. Get rid of the x's and y's. Get rid of the x and y. Oh, well, let's see. No. Sometimes it takes a little creative strategy. For instance, if somehow I squared both sides over here, I squared that side, I get a y squared, I squared that side, I get a binomial squared, and then FOIL it out. Maybe I can rearrange it so I can get plain old x squared and a y squared, and that'll be r squared. So I got rid of some of the x's and y's. Okay, well, but that's going to leave me some piece of the variable x in there, which might be a little more challenging. It might be a 2 or 3 step process. Okay, and then you say, well, okay, what else could we do? Okay, if x equals, okay, here, watch this. If x equals r cosine theta, just make a pure substitution. So make a pure substitution right here for both of these. So if I look at this, that would be 3 times r cosine theta subtract. Okay, and then the y is r sine theta, And that equals to 6. That equals 6. So that was 3x minus y is equal to 6. And in theory, or practicality, in practicality, I've accomplished what I set out to do. I'm done. That's it. The author probably is going to ask you, get the r, well, here it is, express r in terms of theta. R in terms of theta means get the r by itself. Get the r by itself. So then it becomes a little more of a challenging algebra problem. This one here, I'm going to factor off the r. I'm going to greatest common factor off the r. They both have r's, so I'm going to go r parentheses. That would be 3 cosine theta minus sine theta equals 6, and then solve for r. And the back of the book probably has that as an answer. Now, how do you even know that that's correct? I mean, I wouldn't if I were in your place. It looks like magic to me, or gobbledygook, or whatever. Like you're trusting the instructor that I'm saying that this produces that. And you'd say, yeah, sure, right. Prove it to me. So I'm going to do that with the graphing calculator. I'm going to use the graphing calculator, but it's got to be in what's called polar form. Can't graph it, like y equals mx, y, just y by itself. Not going to do that. That's called rectangular form, which I can easily get that in the calculator. No, polar form. Look at this button right here. Okay, the x, this is commonly used by me and you for the variable x, but you're always in function or rectangular form. You see the t that's right here? That's for parametric form, which we might touch on at the end of the semester. That's a theta, that's a circle with a line through it. That's a theta, that's polar form. So I want that one. And n is called sequence form. I won't use that one, but I'm going to do this one right now. So what I do is I do, let's press that button, see what I get. No, let's press the mode. That's what it is. Turn the darn thing on. That's really what it is. Okay, so press the mode. Okay, I want polar form right here. So I press the mode right here. It's the same place where you'd ask yourself, is it degree or radians? So I press the mode. I'm going to go over here and highlight POL. Okay, now I'll back out of it. Now I'm in what's called polar form. And when you put it in y equals, when you're right in an equation, you'll notice that now you've got r equals, not y equals. You got r equals. I got to get rid of that highlight right there. Okay, r equals. That's why I'm saying if the author's probably going to force you to say, hey, put it in r equals, because if you ever have to graph it, that's the only way you can do it. Only way. Sometimes it's almost impossible to get the r by itself without creative algebra. And that's just ugly, sometimes ugly. So, but this one's okay. So I'm going to go second, put the fraction in there, put a 6 in the numerator, and then the bottom down here is a 3 cosine. Okay, now if I press this button, it will be a theta, not an x. Close the parentheses and then subtract sine of that theta. Now, I'm not going to press zoom standard. I'm not going to do that because this is a little peculiar. Zoom standard is really nice when you're in rectangular form because it goes -10 to 10, -10 to 10. Don't do zoom standard. I'm going to press the window just to see what it looks like right now. Press the window. And you're going to see a lot of steps that is maybe not familiar to you. So the first thing it's asking for thetas. What's the theta minimum that you want? Minimum. This is where you say, well, I don't know. That theta is an angle. You might say, well, we've always done 0 degrees, like I'm in degree mode, 0 degrees. How about 0 to 360? We'll just try it and see what happens. So why not? Just investigate it. 0 to 360. See what happens. Okay, now the theta step. That is like, okay, remember the table of values when we do a table feature? I might have shown you a table setup. The table setup will say, what increments do you want the table to use? Like 1s, 2s, every 2, every. So this is saying, what increments of angles do you want? Down here, clear that up. Like, what do you want to start with plugging in? Well, 0. I like to do 0. Okay, fine. We'll start with 0. Then after that, what do you want to plug in? I don't know. How about 1? Like every 1 degree. All right, well, that's fine. We'll see what happens. It turns out when you have, like, we'll put 1 there. That means every 1 degree. It'll plot 361 dots is what that's going to do. It's going to plot it. It's going to take a little bit of time because it's thinking and calculating and thinking and plot, 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 plot. If I did 10 right here, if I did increments of 10, what it's going to do, if you did it on paper, it's going to plug in a 0 into this formula and figure out what you get. And the next one would be 10 degrees and see what you get. And then 20 degrees and see what you get. And 30 and 40 and 50. Okay, and then along the way, it's going to connect the dots, and hopefully you're saying, hope it's a line. That's what it's supposed to be. I'll leave it 10 and see what happens. Then I'll go back to 1 and show you what happens when you have more increments. Okay, the X minimum. Okay, so now think of what this looks like here. One, two, three, four, five, six. How about, I mean, if you say, well, I want to go all the way out here, well, then you have to go probably out to 10. Probably out to 10. Oh, okay. Well, then make it like that's what, 3 there. This is 3, 4, 5, 6, 7, 8, 9, 10. All right, let's go from negative 10 to 10. The X's minimum is negative 10. Let's just because it looks not bad. So negative 10 to 10, and then it'll ask you for the common, well, what's your scalar? Like when we did graphing before trig, scalar is 1, why not? Tick marks. And the Y minimum, let's make that negative 10 to 10. So there's a bit of a setup here. You don't want to do zoom standard. Don't want to do that. And scalar 1, and then okay, you typed in all the parameters. Now you hit graph and see what you get. Now you hit graph, boop, and see what you get. I got a line. Well, I got a line. Which looks like this one. But it's in polar form. Okay, I claim this is a circle centered at 0, -1. That's what I'm telling you right now. The center of the circle is 0, and switch the sign, -1. With R equal 1, radius 1, R equals 1. Okay, 0, -1. Okay, 0, there's -1, -2, -3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, here's the center of the circle, and radius is 1. So up 1, right? Okay, it's going to pass through here, and it's going to pass through there, and it's going to pass through there, and it's going to pass through there. The circle is going to look like this. Yeah, that's pretty good. This is your x-axis. This is your y-axis. So I want to be able to graph that same image using polar. So I need the equation of the polar form. And that's where the work is supposed to be done in this part of the problem. How do you get rid of all the x's and y's? So here's an idea. I'm going to rewrite this. I'll rewrite the equation. And I'm going to target, because I see an x squared, I'm going to target hopefully using this, because if I FOILed out this binomial, I am going to get a y squared. Your goal is to try to get rid of all the x's and y's and just r's and thetas somehow, just r's and thetas. So I'll leave this alone, x squared. This one here has to be written down twice, has to. Otherwise, you make that common baby algebra mistake by, oh, how about, isn't it y squared plus 1, Jeff? Oops. No, it isn't. It's not y squared plus 1. No, it's y plus 1 times y plus 1 and then FOIL. It's not just y squared plus 1. And then you got to do a little bit of work. Y squared plus y plus y plus 1 equals 1. X squared plus y squared plus 2 to the y's plus 1 equals 1. Okay, now the ones go away. They'll subtract. So I got an x squared and a y squared and a 2y equals 0. Here's something very nice. Just so happens x squared plus y squared is r squared. So you make a substitution down here, and now this becomes, just this piece is r squared plus 2y is equal to 0. And one more thing, get rid of the y. And you get rid of the y by letting y equal r sine theta. Y equals r sine theta. Y equals r. So r squared is equal to, no, not equal to, r squared plus 2 r sine thetas equals 0. And now I've accomplished getting the equation in polar form. I have yet, and I would be done unless the multiple choice answer key doesn't show this version, then you'll have to mess around with it to try to see which answer looks like it, but in a different form. So I'm going to try to get r by itself, which is not a lot of work. You go r squared is equal to negative 2 r sine theta. R equals positive or negative. Yep. Square root negative 2 r sine theta. And I have two pieces that I have to put in my calculator. I have a positive piece and a negative piece, because remember, it's a circle. So it's probably going to plot the bottom half of the circle with the negative portion of it and the upper half of the circle. And together gives you a whole circle. So I'm going to put in my calculator right here, y equals I'm going to put in root, second root, negative 2 oh, well, silly me. Silly me. I can't do this the way I'm doing it. I blindly said, oh, let's just solve for r right here. There's an r over here. This is a problem. I can't have r's on both sides. I have to have r only on one side. Well, silly me. This is ridiculous. What I was doing is stupid. I made a mistake. Well, I think I'll have to complete the square. Ugly. I'll have to complete the square. So let me show you something in the textbook. Maybe he's done something just like it, the same problem, the author. I mean, I can complete the square. I'd rather not. We'll looking for another hint, possibly, if there's some different way of doing it. 6.3. That's it. This is the one right here. Now, it's actually an extra problem. It's not one. See here's the exact problems I took right out of the book, but they're checkpoints. They're not worked out. Okay, let's see. Hey, that answer, I don't know if you can see that Zinnia in light blue. Can you see the light blue right there? Yeah, so that's what I got in the last problem, that exact form. So here's what they've got over here. R equals -2 sine theta. I'm gonna go back and see if I've made any careless mistake prior to, that looks pretty simple. Let's see. Oh, no, That's R squared. X squared plus Y squared is equal to R squared. No. Okay. I'm going to look at a previous problem he did. It might be similar. It's similar. See right here. I'm on page 739 if you're wanting to reference this, page 739. I see what he's done. He took a different approach. Okay, I like that idea. So what he did is he made X into R cosine theta, and he made Y into R sine theta. He approached it that way. Okay. That's not what I did, but I'll try that. Because it looks like the only other way for me to finish this up is to complete the square. And right here, complete the square, and I'm resisting doing that. So I'm going to go back to the drawing board, because I see his little idea, and rewrite this. And X is R cosine theta, but then you got to square it. And then plus R sine theta and a +1, and going to have to write this down twice. Okay, this right here is R squared cosine squared theta plus, write this down twice. Let's see if I've got enough room. Okay, FOIL, R squared, oh, not equal. Silly me, silly. So FOIL, let's see, that would be plus R squared sine squared theta. Okay, now the outer and inner are like terms. Okay, so I have two of those guys. They look the same. The outer, oops, should be outer out here, and inner are the same. And so 2 R sine thetas. Okay, so +2 R sine thetas, and then +1 is equal to 1. okay, just like the last one over here, the ones go away. So those go away. Now I'm left with r squared cosine squared theta plus r squared sine squared theta plus 2r sine theta equals 0. Yeah. What's funny? What's to me, I'm going to get to the same place right here. look at this. So what's funny is this is going to get me the same place. Oh my gosh. Right back to where, okay. Factor off the r squareds. That's what they did in their textbook. Factor off the r squared, parentheses, cosine squared theta plus sine squared theta is the famous number 1 identity back in chapter 4. So that's going to be a substitution there. All right, sine theta is equal to 0. Okay, r squared times 1 plus 2r sine theta equals 0. Okay, that's the same thing as right here. Oh my gosh. Okay. Oh my gosh. I'm looking at my book. All right. A little cheating here. Fine. No. No. Okay. They factor. Okay, they're going to solve for r. Okay, it's simpler than what I thought. They're gonna factor out the r, which is, I'll just do it down here. More room here. So r parentheses r plus 2 sine theta is equal to 0. That means in algebra, r equals 0. In algebra, r plus 2 sine theta is also equal to 0. In algebra, solve for r. R is equal to negative 2 sine theta. And those are your, in your textbook, those are your equations. That's it. Now, this one's not interesting. If the radius is 0, what do you got? Radius is 0. I have no length. I don't know. I have no, that's a theoretical. Is it nothing? Is it a black hole? Is it something? Yeah, so we're, that's silly. But this was the one that I'm going to put this one in my calculator right here and try to get this circle that was back up here. Remember this circle? I'm going to put this in my calculator right here. So clear that out. Negative 2 sine theta. I'm going to go back to my window feature. Sure, let's go from 0 to 360 again. Sure, why not? See what happens. Okay, now, the x minimum. If I go negative 10 to 10, it's going to be a very small circle, hard to see. I think I'm going to go negative 3 to 3. You see how the circle only goes down to below is negative 2? I'm going to make my viewing screen from here to here to here to there. I'm going to make my viewing screen right there. So that's the x's and y's. So I'm going to go x min is negative 3 to 3, scaling 1, and then negative 3 to 3 again. And then I'll keep my fingers crossed and press graph. Oh, that's a crap circle, don't you think? That's awful. Looks like I don't know what that is. It doesn't look like a circle. Here's two things about this. Your viewing screen physically right here is not a square. Your viewing screen is actually a rectangle. It's longer than this way. So if you look at the distance, these are supposed to be incrementally the same here as it is down here, but they're not. visually. They are, but they're visually. So what you could do is what's called, we're going to square it up. Zoom square like this. Zoom. Okay, now after I did that, I'm just do zoom square, which is number 5. It'll redo it, but it'll make it a little better. It's a little better. A little better. Back to window. Remember this 10? That means it's going to jump by 10 degrees. What if I did this by like 90 degrees? And all I'm plotting is what, 0, 90, 180, 270, and 3. I'm plotting 5 points. That's all I'm plotting. I'm going to hit graph and show you what you get, if anything. Nothing. Nothing. Why nothing? Okay, let's go back here. Window. 0. If you go back to here to 0, what's sine of 0? Anybody, what's sine of 0?
It's 0.
Oh, thank you. Oh, okay. I woke up. Okay, so, well, when the angle's 0, the radius is 0. I don't know what that is. Well, maybe it's the origin. Maybe it's the pole. Probably is. Oh, okay. Let's try another one. Okay, every 90 degrees. Okay, 90 degrees. Let's do that. Okay, what's the sine of 90?
The sine of 90 degrees is 1.
Oh, it is. Okay. So, so now you've got r equals -2 times 1 is -2. When if you make a table of values here like this, it's r and theta, sorry, r and theta. You go 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. This was 0. This was -2. Okay, 180 degrees. Sine of 180 is back to 0. So that'll be 0. 270. Okay, sine of 270 is actually -1. Yeah, -1 times -2 is +2. And 360, we're back to 0 again. So if I'm going to plot those, just those 5 ordered pairs, it's going to look like this. It's going to plot it here. Okay, so r is negative. So 90 degrees, remember 90 degrees goes up here, but r is -2, so it's going to go down here. Okay, 0, 180. Okay, so 180 degrees is over here, and 0, back over here. 270. Okay, so 270 is way down here, and it's 2. So put a dot right there again. 360, same thing. So all it's doing is putting dots. Origin, -2. Origin, -2. Jeff, are you serious? I don't see anything. I know. The calculator doesn't put the dot very good. I don't see anything. All right, well, how come I got something with 10? Because it'll have something for 10 degrees and something for 20 and 30 and 40 and 50 and 60 and 70 and 80. It had something for 90 degrees. It just wouldn't have anything for some of the few of the other ones. Oh, okay. So if I'm go over here and I change my window and I make that into, oh, let's go 45. 45 goes into 360. I'm curious what that would look like. Well, that's not a circle. All they're doing is plotting and connecting the dots somehow. So what they're doing here is is they're plotting and connecting the dots. It's really a line in between those two dots, which you can't see on the graph. You can't do that. Well, that's not a circle. So it turns out that you want more. I did 10 degrees. Let's put 1 degree. So it's going to plot 365 dots. The more step, like the smaller the step, the more dots, the longer it's going to take the calculator to plot. I'll say it again. That was pretty fast what it did with just 45 degrees. When I do 1 degree, let's see how slow it takes. I'm going to press enter right here. See, look at, yeah, slow, because it just was more. So if I went back over here and say, come on, where are you? Where's the window? Come on, where are you? Wait, it's still working right here. Okay, window here. And I went 0.5, so a half a degree. Slower. Slower. It's got more dots to plot. When we get into the section on parametric, it's almost identical. The concept is identical. See, I'm able to graph non-functions using polar, and you're able to graph non-functions using parametric as well. But functions are just functions. It has to pass the vertical line test. Anyway, that was fun. I haven't done that one for a while. Going the other way. Do I want to do either one of these? Okay, I can do one of these. Sure. Okay. This goes the other way. So this is a Jeff, where's the theta? Ain't there. So that means you can use any angle you want, any angle, but the radius is always going to be 4. Any angle. Well, what does that mean? What's the picture look like? Well, you put it in maybe rectangular, it might be more recognizable. How do you get rid of the R? I don't want any R's or thetas, so I don't necessarily do that. Gosh, okay, here's an idea. Couldn't I square both sides? Here's an idea, square both sides. Sure, let's do that. So now I've got an R squared, X squared plus Y squared is in fact the same as R squared. So you got X squared plus Y squared is equal to 16. So these, both of them, this is polar and that's rectangular, produces a circle. Produces a circle. Yep. Okay, so this one, how do I get rid of the theta? Gotta get rid of the theta. Theta. I could do tan inverse, let's see, and get theta is a tan inverse, but that gets kind of, I'm not sure I like that. How do I get rid of the theta? Well, I can solve for theta, but I'd still have an R here. That's a problem. Looks like this is the only thing that is a possibility to get just X's and Y's, but I'll have a tangent thing in there. I'm going to show you what the author does. Let's see if he does one like this. He does one like mine, or I picked one like his, I should say. So I picked one like his. Okay, letter B. I'm on page 740, referencing the textbooks, page 740. B, we'll look at B. Okay, that's what they're going to use is tan theta to convert. Okay, let's see what they do here. So they did tan both sides. That's what he did. He went tan both sides. So then tan theta is equal that. Okay, so then tan theta is the same as y over x. Tan of pi over 4 is 1. Okay, solve for x, or get the variable out of the bottom, so y equals x. Oh, okay, y equals x. So I'm going to do his strategy. Over here, I'm going to go tan to both sides. So tan theta is y over x. Tangent of 3 pi over 4. Huh, crap. I don't know. Well, 3 pi over 4 is in quadrant 2. 3 pi over 4. Okay, that's over here. The x's and y's are the same. So they're going to just go to, well, let's see. That's going to be negative. So I think it's -1. I think it's -1. You guys check me out, see if it's true. Just take your calculator and go tan of 3 pi over 4. Tell me if it's not -1, because then I need to go back and check. I believe it's -1. You multiply both sides, you get y equals -x.
It's -1.
So the equation, the picture that this produces is a line that looks like that. And finally, this one, the strategy I'm going to use for this one is square both sides. That's what I'm going to do. So if I square both sides, I get r squared equals 100. Let's see if this will work. Yeah, I do this. Sine squared theta. R squared is x squared plus y squared from above, 100. Okay, and then sine theta. Okay, sine theta changing my mind slightly here. Okay, so it appears that r is going to be 10. No, I say take that back. R is 10 sine theta. Okay, let's see. What else do I have? Sine squared, sine squared, sine squared. Yeah. Sine squared theta. Sine squared theta is equal All right. All else fails, go to see what he did. I thought I had it. Let's see if he did anything like this. He did something similar, like a letter D. Letter D. Okay. Letter D is very similar. So I'm going to look at his answer for letter D. I just need a hint. Okay, yeah. So, oh, instead of squaring it, he just multiplied through by just R. See, I squared it. A little different. I'm going to multiply both sides by R. Yeah, that's the key. So then R times R is equal to R times 10 sine theta. This is R squared is equal to 10 R sine theta. This is x squared plus y squared, x squared plus y squared. There's plain old 10. And now there it is. R sine theta is y. R sine theta is the letter y. Yeah, I got hung up on that one. And so there you have it. There's an equation of something. I'm not going to try. This one will require completing the square, and I'm not going to do it. And I'll just see if he did anything like that. He did. He went through completing the square, and you can see how he did it and be reminded about it. I'm not going to do it. Okay, I think I'm at the end of 6.3, at least the packet pages that I have. When we get into 6.5, I'm not sure if that's the next one, but 6.5 could be back to imaginary numbers, back to imaginary and polar form. But that's for next week. So remember, no class on Thursday, no class on Thursday. And I'm going to go in and release my quiz number 4. I said that wrong. Oh my gosh. Quiz number 9. I'm getting tired. Okay, now let me know, Matthew, if you see daily quiz number 9. That's what I just made green. Anybody else? Put your imaginary emoji thumb up if you see number 9.
It's
not-
open.
Okay.
It says no due date, but I can like take it.
Say it one more time.
It has like it says like no due date, but I can take it.
No, it's got no due date, but I will say, if you look at my course outline,
Yeah.
my course outline says, but today, if you feel like you need to step away, I've been a little slack the past 2 baby quizzes, and I've allowed it to stay open to see if anybody wanted to do it in their own time. So I'll do that also, but be aware, probably tomorrow, if you wait too long, it's gone. I'll shut it down. So if you want to do it later on the night, no problem. You don't have to be with the group today. Those of you that want to stick around with the group, I'll put you in breakout rooms, and there's only 5 problems. So I'll have it up through tomorrow, available. Otherwise, stick around, and it depends on how many people stay around. Might be just 2 groups. 2 groups of 5, 4. That way you get a chance to talk to others, pick their brain. Okay, so looks like everybody else is staying?
I'm leaving because I have
Okay, man.
other things to do. But,
Yeah, no problem. Anybody else feel compelled to take off? Oh, I just lost another. Anybody else compelled to take off? So I see, let's see, 3, 6, 7, 8. Oh, 2 groups of 4. Okay, that's good. 2 groups of 4. Oh, lost another. Down to 3 and 4. Okay, we're still okay there. Okay, one last chance. I don't want to put some people in a group and all of a sudden people bail and there's only 1. So anybody else taking off? Okay, so 2 groups. Let's see who's in it. Yeah, 1 group of 3, 1 group of 4. Okay, I'll be around if you have questions.